Hello everyone. In this video, I'm going to go over a few questions that will be in your test 1. This is me. Now, this is me when I had my blonde hair. Now it's with somewhat red. Okay, so my idea of this video will be, I will go over 15 questions. Hence, your exam is 15, your test is 15 questions too. So I will go over 15 questions. Whatever you see in red, like here, the distance formula, you will not see this in the test. So you have to know this, okay? So the questions will be at the top. They're all numbered. So for example, number 1. And then I'm going to attempt to work all the details of each single question. And I will try to show as much depth as possible, okay? So let's go ahead and get started. Bring my key thing. Okay, so question number 1, it says, find the distance d P1 and P2 between the points P1 and P2. These are the 2 points that were given right here. This is the distance formula. D, the distance of P1. Oh, this is supposed to be a little one here. Little mistake here. P1, P2, which equals the square root of x2, so second point, the second value of x minus x1 squared plus y2 minus y1 squared. Okay, so the first thing I'm going to do is, after having my formula, is to label my points. So I'm going to label my points. And excuse my writing, not the best when it comes to writing in here. Okay, so I'm going to go ahead and label my points. This is x1, y1, x2, y2. Once I have labeled my points, I'm going to go ahead and substitute into the formula. Okay, so I have the square root of x2, which is 2, minus x1 squared plus y2 minus y1 squared. Notice the formula has a negative and you're substituting a negative number, and that's why I have the double parentheses. Okay, so now this is going to give me negative times negative is a positive, so 2 plus 2 is going to give me 4 square plus 1 minus 5 gives me negative 4 square. Okay, so then this is 16 plus 16. Square root of 16 plus 16 gives you 32. If you go ahead and simplify that, you're going to go ahead and have 4 square root of 2. Where does that come to be 4 square root of 2? If you take the square root of 32, you can break it into the 6 square root of 16 times square root of 2. Square root of 16 is 4. The 2 is not a perfect square, so stays. So this is your distance between the two points. 4 square root of 2. And you want to leave it in radical format. Do not put it as a decimal. Okay, so let's go see one more question. This is not okay. Let me go ahead and give a space here real quick. Okay, perfect. Let me see. Oh yeah, perfect. Okay, let's continue. Let's use a different color. Okay, we have another example asking us to find the distance between the 2 points. Again, the first thing I need to do is know my formula. The second thing I need to do is label my points. Okay, that way I don't make a mistake. So I'm going to go ahead and do that. And then P2 equals 2, comma 2. Let me lower my chair a little bit. I feel like I'm too high. Maybe that's why I'm writing more horrible than before. Then I'm going to go ahead. My third step will be to substitute the points. Okay, so let me finish labeling. I didn't do that. So I have the square root of x2, which is 2 minus x1 square, plus 2 minus, ooh, making a mistake there. Let's rewrite that. That does not look like it's supposed to be. So yeah, you definitely don't want to rush through any of these things. As you can see, it's easy to make a mistake, and you don't want to make a mistake. Okay, so I substitute my points into my formula. And I'm going to go ahead and subtract this. Is going to give me -2. I'm going to square it. And then this here, negative times negative is a positive. So you're going to get 6. Okay. So I'm going to go ahead and have 4 plus, what is that, 36? Yep. Add that, gives you 40. Simplify that, gives you, what is it, 2 and 10. Is it 2 and 10? I think so. But let's see how. Why is it 2 and 10? Okay. Okay. 2 and 10. But why? If you take this and you break it into one perfect and one not, between inside 40, you have the square root of 4 times the square root of 10. And then the square root of 4 is 2, and the 10 is not a perfect square, so it stays inside. So the distance between the 2 points is 2 square root of 10. Okay. So that was the second example. Let's go ahead and see what is the third example about. And let's keep changing colors as we go through this. Let's just keep playing a rainbow here. Example 3 says, solve the following equation by completing the square. Okay, so the idea of this, the first step for completing the square is you want to always check that the A term is 1. So, and if it's not 1, you want to divide everything by that number. In this case, the A term is already 1, so we do not have to worry about that. The second thing is you want to have the third term, which is the C, on the right side of the equation. In this case, it's already there. I'm referring to this number right here. So because the first step and the second step are already done, we move on into the third step, which is to take the middle term. So take the middle term. I'm going to write it here. Take the middle term, divide it by 2, and square it. Okay, so this is what I'm doing. Middle term is 4, divided by 2, square it. 4 divided by 2 is 2, 2 squared is 4. So this is step 3. The only reason why step 3 is because step 1 and 2 are already done for us, okay? And these are the things that you have to be able to recognize. Now, step 4 is to add the answer from step 3 to both the left and right side of your equation. So x squared plus 4x. I'm going to add something here. And then I'm going to add something here. So this 4 comes from here. Plus 4 plus 4. Okay? I'm going to go ahead and rewrite this so it looks a little bit prettier. Don't think it might be possible, but I can try. Okay, now step 5. Okay, so in step 5, the left side of your equation becomes a perfect square trinomial, which means you can rewrite it like x plus 2 square equals 81. Okay, why does it become a perfect square trinomial? Well, let's see. I'm going to go ahead and do this work on the side. I'm going to take the x squared plus the 4x plus 4, and I'm going to factor it. Factors of 4 that add up to 4 and multiply to 2. And multiply to 4 is 2 and 2. So I'm going to go ahead and rewrite this. X plus 2 and 2. Notice how the two terms are the same. They are the same. So I can go ahead and just rewrite it like this, which is what we have on the left side now. So the left side becomes a perfect, let's write that down, square trinomial. Okie dokie. So now in step 6, we're going to solve using the square root method. Okay? So I'm just going to go ahead and rewrite it here. And for the square root method, I'm going to go ahead and square root both sides because the goal is to cancel the little square over here. So this and this cancel. So now I'm left with x plus 2 equals plus or minus, because every time you do this part, square root it, like this, you add the plus or minus, and square root of 81 is 9. So then we'll go ahead and minus 2, because we are solving for x. Okay, so now I have x equals negative 2 plus or minus 9. This we can rewrite it because it's 2. So x equals negative 2 plus 9, and x equals negative 2 minus 9. This gives you 7, and this gives you negative 11. And those are your two values. Okay, for x. And this we solved it by completing the square. Okay, let's see this number 4 over here. It says solve the following inequality. Graph the solution set. Okay, so the idea of, you see this right here, is I am writing to you the theorem that goes with this example. So what to do when you have this symbol and you're solving a compound, I can't even say it, Dios mío. You're solving an absolute value inequality, okay? So the theorem says, if A is a positive number and if U is an algebraic expression, that is referring to, let's say, the 12 is A, and the U is what's inside the absolute values, which is a 17 minus 2, okay? So these are the two scenarios. If you have this symbol, okay, so you're going to say the absolute value of U is less than A. You can rewrite it as, which one do I have? I need the black. As this right here. This compound inequality. Okay, I cannot make straight lines in this thing. And if you have this symbol over here, then you can rewrite it like this. Okay, in other words, you could also rewrite it like this, which is the same. Okay, so now let's see. Now remember, this theorem, it will not be there when you're taking the test. Okay, so we need to know. So this is what we have. So we are dealing with this one right here. So A is a 12, U is a 7t minus 2. Okay, so now let's, using this one that I just put a little check mark here. So A, I'm going to have a negative, right? So I'm going to say negative 12. Then I'm going to use my symbol here, and then I'm going to put what I have for U. Okay, and then I have the symbol again, and then I have a positive A. And now solve. Okay, so using my theorem, I figure out which one of the two goes with it based on the sign that the problem has from the beginning. And then I construct my compound inequality, and now I simply solve. So you're going to solve from inside out. Inside out, which means I'm going to first add this 2 to all the sides. Okay, gives me negative 10 less than or equal to 17 less than or equal to 14. I'm going to go ahead and divide. Sometimes I can make straight lines and sometimes nothing. So this cancels. So then I have negative 10 over 7 less than or equal to t less than or equal to 2. Now, notice I solved from inside out. Everything I did was to leave the t by itself. Now, they need me to graph my solution and give my answer in interval notation. Okay. So I'm going to go ahead and graph my number line. Oh, almost a straight line. Barely happens. Barely happens. The negative is over here. The positive is over here. I know that this is positive infinity. I know that this is negative infinity. I always put 0 in the middle to guide me. I know that based on the signs, because it's equal to, I'm going to have closed dots. Okay. I'm going to have closed dot. And then I'm going to read from the variable. Okay. Now read from the variable. So inside out, inside out. Okay. So t is greater than or equal to negative 10 over 7. That means it's going to the right. All positive numbers are going to the right. And then it says t is less than or equal to positive 2. All numbers less than 2 go to the left. So then from where to where do the two lines overlap? So if you notice, one line, I like to use my shading like this, goes this way. And then the other line goes this way. So the question is, from where to where do the green and pink overlap? They overlap from negative 10 sevenths. I keep wanting to say 7 to 2. Both have brackets because the symbol, and I have closed dots. And this is your interval. This is your answer in interval notation. Okay. The solution set. So keep in mind, I was able to construct the compound inequality based on the theorem. Okay. And we're going to see another example about solving absolute value inequalities. Okay. So again, let's just keep changing the color, bring different colors to our eyes. That way we don't fall asleep. Okay, so here we're going to solve number 5. Here, I got my notes on the side to make sure I stay on track. Okay, so we're going to solve the absolute value inequality. Again, I am giving you the theorem. Okay, so if A is a positive number and U is an algebraic expression, then this follows. Okay, this is helping us rewrite it in order for us to solve it. So which of the two signs are we dealing with? This one over here. So this is the one that we're going to follow, right? So I'm going to go ahead and write it. Okay, I know that my A is the 5, and I know that my U is a 4x minus A. So now I'm going to substitute this information into this setup right here. Okay, there's supposed to be a little space here. So just know that, okay? So U is 4x minus A less than or equal to negative A, so negative 5. Or U, 4x minus A is greater than or equal to positive A, which is 5. Let me rewrite that 5 again. It looks a little weird. Okay, still weird. Let's just solve now. Now we're going to go ahead and solve. Solving for x. I was about to put an equal sign. Sometimes it's confusing. You're so used to solving equations and then you have inequalities and you forget. Okie dokie. So last step is to divide. So we have 3/4. And then we're going to go to the other side. In this case, we're adding the 8. We have left with 4x greater than or equal to, what is that? Take 2, 10, 13. Perfect. Divide by 4. Cancels. X is greater than or equal to 13/4. So now we have to go ahead and graph our answers in our number line. Okay, I'm going to put all the information. I always like to do that. It helps me see it clear. So 3/4 is somewhere over here, and 13/4 is somewhere over here. And then based on the symbols, they are closed dot. Make sure we know when they're closed dot. Just in case you forgot, I'll write it over here. When is this or this? Close dot, bracket. When is this or this? Open dot, parentheses. And then the infinities always get parentheses. Okay, just in case you forgot. Now we're going to read x is less than or equal to 3/4. All numbers less goes this way. And then x is greater than or equal to 13/4. Or all numbers greater go this way. So I don't really need to do my shading because you can already see where the arrows are going. And we're dealing with an OR statement, so we're going to go ahead and rewrite it using the proper symbols. So we read this left to right. Read the graph. Oh, not writing. Okay. Graph. Left to right. My little pen is not functioning. Infinities always get parentheses. Close dot, get a bracket. In order to connect both solution sets, I use the U. Then I have bracket. 13/4, positive infinity, close parentheses. Okay, let me go ahead and box your answer. Perfect. And this is your answer in interval notation. Okay, so again, I follow my theorem that helped me determine how I was going to rewrite the inequality in order for me to solve. Okay. Once I have solved, I graphed it to help me write my interval notation. Okay. And here we have a simple absolute value equation. So the first thing when it comes to an absolute value equation is that you want the absolute value to be by itself. If the absolute value is not by itself, then you need to isolate the absolute value. So in this case, if you can see your absolute value, it is not by itself. So we're going to go ahead and isolate it by subtracting the 3 to both sides. Okay, so this gives you 11. Now we're going to go ahead and rewrite it into our two equations, one equaling to a positive 11 and one equaling to a negative 11. So we're going to do 2 minus 3t equals 11, and then 2 minus 3t equals negative 11. And now it's just solving, isolating the variable. 9 divided by 3, beautiful work. Negative 3. And then we do the same on the other side. The key thing about this question is the fact that you have to isolate, what is that, 13, right? 12 or 13, yeah, perfect. You have to isolate the absolute value. If you don't isolate it, you probably get one of the two answers right, just one. But you don't want to do that, right? What is that? Negative and negative gives you a positive, so it's 13 over 3. So the solution set is negative 3, 13 over 3. Okay. So I put in from smallest to greater. This is the solution set. So again, the key is to start by isolating. I have spelled that wrong. The absolute. I might have spelled that wrong too. But you should know how to spell it. Okay? Once you have done that, then you go ahead and break it into your two equations. Cool. Excellent. Okay, that was 6. Let's move on to number 7. Okay, question 7. We need to find the real solutions of the equation. This is the square root equation. So let me go ahead and rewrite it. Man, it looks so pretty here. And then when I write it, it's just not pretty. Okay, so in order to solve for this one over here, I need to cancel the square root. So I'm going to go ahead and square both sides, because the opposite to a square root is to square it. So that leaves me with 5x minus 5 equals what? 25. Then I add the 5. Okay. And that gives you what? 30. Yep. This green is kind of cute, and then it's kind of not. So then x equals 6. And then you want to check if that's a real solution, if it actually works. It doesn't make this undefined, but it's not true. So I'm going to go ahead and check it. And to check it, I just need to substitute the value I found for x into the equation, which in this case is 6. Okay, so then that, what is that? 30 minus 5. 30 minus 5 is 25. Square root of 25 is 5. So yes, that does work. This is a valid solution. Valid. That looks bad. Let's write it again. Valid. Okay, beautiful. So again, you want to make sure that the square root is by itself if you can. There are questions that you won't be able to isolate the square root, which is fine. But in this case, it was already by itself, so we were good to go and just go to the step where you cancel right here. Let me just do that first. Oops. Where you cancel the square root by squaring both sides. Okay, that's the key part. After that, it's just solving for x. Okay, we have another absolute value equation. The only difference for this one is we have fractions. No problem. We are amazing. We can go ahead and work with fractions. We are not scared of them. They don't do anything. You know how do we work with fractions? We cancel those fractions out. And then that's it. So the absolute value, it's by itself. So we're going to go ahead and rewrite it into our two equations, one equaling to a positive 5 and one equaling to a negative 5. Okay. Okie dokie. And then we're just going to solve. So I'm going to start solving this by canceling those fractions, like I just said. So the LCD is 12. 3 times 4 is 12. So I'm going to go ahead and cancel everything by 12. I'm just going to go ahead and write it over here too, because since I have the green pen, I'm going to go back to that purplish pinkish. So this is what I do. 12 times x is 12x. Divided by 3, 4x. 12 times 3 is what? Oh, I forgot, 36. Divided by 4 gives you 3. 12 times 5 gives you 16. Man, I lose my multiplication. And then I go ahead and make a mistake. Oh man, did I do that part wrong? Let me see. 12 times 3 is 36. Divided by 4, it is 9, not 3. You guys, make sure you caught that mistake. Okay, what was that? 12 times 3, 36 divided by 4, 9. And we put the 9 and they equal to 60. That would not be good. Good thing I caught that mistake and hopefully you did too. And subtract that, that's 51, right? Right, now I'm gonna question all my answers. Because sometimes apparently we cannot divide 51 over 4. That looks fine. Okay, so then we go on this side. We're going to get the same thing. The only difference is that we're going to get a negative 60. So then we minus. Oh, I'm getting kind of hungry. Even though I just ate something. Ay. So then that's negative 69 over 4. Okay, and again, we're supposed to write our solution set from smallest to largest. Okay, we put our absolute value, our brackets, and that's it. That's our solution set. So the key part for this question, I think, is the fact that you might not like fractions, but we can work with them, so no problem there. We just get rid of them. That's the cool thing. Also, making sure from the beginning that your absolute value is by itself, which it was. And then going ahead and rewriting it into equaling to a positive 5 and a negative 5. Once you do that and you cancel your fractions, you are left with two simple two-step equations. Okay, and then don't make the mistake of this, this thing here over here. Don't do that. But it's okay if you make mistakes while you are practicing, but not while you're taking the test. Okay, so we get into the somewhat maybe let's not think about it like that. More challenging questions. Okay, so first I'm gonna go ahead and give you a little bit of information. Now remember, this that you see here in red, this you will not have available, so you need to know this. Okay, now the first thing you're gonna do, you're gonna have different types of variation. Okay, so let's figure out which one is it. So the example says the velocity of a falling object, ignoring air resistance B, is directly proportional to the time t of the fall. So you see this right here, directly proportional. Okay, so you're dealing with direct variation, right? To the time t of the fall. If after 3 seconds, the velocity of the object is 96 feet per second, what is its velocity after 6 seconds? Well, let's review a little bit about the direct variation. So direct variation varies directly. That's one option, one possibility. Let's think about it like that. or directly proportional, and a constant of these are some what of difficult vocabulary for me. Proportionality. I am 100% sure that you can pronounce that better than me, so just, bear with me. Okay, so the idea is you're going to let X and Y denote the two quantities. So this is what we're using, and that's why you see this over here. Okay, then Y varies directly with X. So that's one of the options to help you determine which variation you're dealing with. Or Y is directly proportional to X. And then it says if there's a non-zero number K, for which a number K is called the constant of proportionality. I'm going to continue trying to practice pronouncing the beautiful word, but still, no matter how many times I practice, it still doesn't come to mind. Okay, so which one am I dealing with? B is directly proportional. So we're dealing with the second part right here. Y is directly proportional to X. Okay, now the idea of this type of problems is once you know which type of variation you are dealing with, okay, then you want to write your model, okay? Once you have written your model, then you're going to be able to solve for the question that the problem is asking you. In this case, what it is the velocity after 6 seconds. Okay, so the model to follow is this one over here, where Y varies with X. So what we don't know is the K. Okay, so now let's first label because if you notice we're given the Y and the X, but here it says B and then T. So so it says B is directly, and I'm going to try to write it, proportional to T. Okay, now I need to know B is the velocity. So I need to know what each variable means, which is easy right here, but it's good to practice. And T is time. So my model that I'm going to follow will be like this. B equals KT. This is my model for this problem. Okay. So I have that. Very good. Now what do I need to do? I need to find out K. So I'm given some information, right? I'm given the time, which is after 3 seconds, and I'm given the velocity, which is 96 feet per second. These two numbers are going to help me find the K. That way I could have a model that will work with this example and help me find the velocity after whatever seconds I want, which in this case is 6. Okay, so now I need to find K. I need to find K. I need to find K. Let's find K. So I have a velocity of 96. Let's use different color. This blue is not that beautiful. 96. I don't know K. And I know that the seconds is 3. So once I do this part, okay, I divide by 3. K equals 32. Okay, now that I know that K equals 32, I can go ahead and say the velocity equals 32 T. With this right here, This isn't model for this exercise. Let's put final model, because this one is like in between. With this, you could give me whatever time you want or whatever velocity you want, and I can find either of the values. In this case, the problem said they want to know the velocity after 6 seconds. So I'm going to go ahead and substitute the 6 seconds for t and see what is the velocity. Okay. And that gives you 192 feet per second. Okay. So that seemed like there was a lot. Maybe we need to go back and talk about the process, right? So you're given an application, right? And the application is referring to directly proportional. So from what we learned, we're talking about direct variation. Okay, so two things. It could be y varies directly with x, or y is directly proportional to x. The model to use to start the problem is this one right here. I want to use a different color. Let's oops. Let's like that big red. So the model to follow is this one over here. Okay. I go ahead, label my variables. I know b is velocity, t is time. I know that I am dealing with b, this was b, is directly proportional to t. I think I erased something there. B directly proportional to t, right? So now I know, and it's referring to the second part of the definition, right? Okay, I do know once I have labeled my variables, using the given model, right, the definition, I can go ahead and construct the one that has my variables for this exercise. Now, once I have that, given the information, I need to find the k value. So this is what I do right here. Find k. Once I have k, I am able to construct a model that's going to help me find the velocity after a certain amount of seconds. And I could go ahead and ask you again, after 7 seconds, what's the velocity? After 10, and so on. Or I can go ahead and give you the velocity and ask you to find time. Because once you have the value of k, you are able to construct the final model that will answer the questions for this exercise. And once we do that, we get our answer. Okay? We're going to see 2 more examples with variation. And here's another one. Okay. So let's just go ahead and read it. The electrical resistance R of a wire varies directly with the length of I, of a wire, and inversely with the square of the diameter d of the wire. If A were 650 feet long and 5 millimeters in diameter, has a resistance of 1.25 ohms, find the resistance in a wire that is 510 feet long with a diameter of 4 millimeters. I don't know to you if that was the same feeling to you, but to me that was like a lot to read. I need to go back and read it like a million times, not that many, and just digest it. But keywords: varies directly and inversely. So 2 types of variation working together. And this is when we have a joint variation. Okay? When a variable quantity Q, example, is proportionally to 2 or more variables, we say that Q varies jointly with these quantities. In joint variation, combination of direct or inverse variation may occur. So these are the two, okay? So the same thing. First, we're going to start by identifying the type of variation, which we already did. It's joint variation because varies directly and also inversely, okay? Then let's go ahead and look at all the variables that we were given. Okay, we're talking about R, I, and very important, the square of the diameter D. The square, D square of the diameter D. So then we're going to go ahead and, well, what each variable is. Electrical resistance is R. So electrical resistance. And the I is the length of the wire. Okay. It's just taking the problem and just, breaking it apart. That way we can understand it better. And then D square is the diameter of the water. Diameter of the wire. I've never been very good with pronouncing W's. It's weird. Okay, so what do we know? We knew that the electrical resistance R of the wire varies with the length of I. So we know that R varies directly with I. Okay, we know that. And then we also know that R varies inversely with the diameter, which is D squared. Okay, so those are the things that we know. And knowing what each variable stands for and whether they vary with, we're going to be able to construct our model. And just like the previous example, once we have constructed our model, what are we going to do? We're going to need to find the K. Okay, that constant. And then we're going to have the final model. And this model will help us answer any questions in this scenario. Okay. So using this right here, oh man, using this both variation, we're going to have the same. We're going to have this. We're going to have the I at the top and the D in the bottom because let's say R, in this case Y, varies directly with I and inversely with D square. So R varies directly with I and inversely with D square. And then we have the constant K. So now let's just substitute the information that we're giving in this example so we can go ahead and find the K. Okay. If the wire was 650, let me use the little highlight thing because apparently I don't do very well with straight lines. So the wire is 600 feet long. So that's I. 5 millimeters in diameter. That's D squared. And has a resistance of 1.25 ohms. That's the R. So I'm going to substitute those values in here. So I have 1.25 equals 650 over 5 squared and K. No mistake. Oh, I'm running out of space. How beautiful. Once you have solved this over here, you're going to go ahead and get a decimal. So let me go ahead and, So this gives me 25, right? 25. In order to cancel the fraction, I'm going to multiply 25 to both sides. Okay. I'm going to multiply 25 to both sides. I don't know why this keeps happening. It's a distraction to our life. Okay. Did it erase something? Let me see what did it erase. Can see. It erased something over here, right? I have no idea what it erased. No idea. I think I know. It erased, I had here inversely. Let me write it. Inversely. I don't know why it does that. Inversely with d square. I'm going to go ahead and try to take less space. 1.25 equals 650k over 5 squared. Okay, I need to solve for k. Step 1, 5 squared is 25. Step 2, multiply 25 by both sides. That way I get rid of the fraction. That leaves me with 31.25 equals 650k. Divide both sides by 650k. 650k. K equals a very long decimal, 0.04807 9231. You might ask, Professor, do I need to keep the entire decimal? Yes. You don't round until your final answer. Okay? You do not round within a problem. You round at the end in your final answer. Okay? Now that we know K, we can construct our final model. And this is the model that's going to help us answer any questions. Okay? So the model will look like this. I'm going to take a little space on the next page. R equals, and then we have to write the big decimal again, 0.048079231 over the square, and then this is, remember, the I. Okay, now that we know that, we can go ahead and find the information. So what is it? It says find the resistance if the wire is 500 feet long, which is I. That does not look like an I. Okay. Okay, you know it's an I. And then it has a diameter of 4, which is d squared. 5, 10, 4. Don't get confused with that one. Okay. So again, we're going to go ahead and say this is a lot of writing. Don't listen to my complaining, okay? You don't complain. That's a 3 and a 1. And you're going to multiply that times, what is it, 5, 10? And then you're going to divide that by 4 squared. Okay, once you do that, you multiply the big decimal times the 510, then you divide that by 16, you're going to get 1.53. And that's 1.53 ohms. Whew, that was a lot. Let's talk about it. Okay. So with any application, you first read the problem. Okay. We're dealing with variation. It says it clearly there. Variation. Okay. We're dealing with variation. Varies right there. So we're dealing with variation. Well, which type of variation are we dealing with? Based on the given information. Okay. We're dealing with directly variation and inversely variation, okay? Once we have realized that we are dealing with a joint variation, which is two working together, we go ahead and, identify our variables. We are dealing with 3 different variables. What does each variable means? Cool. Once we have that, let's figure out which variable varies with which. So in this case, the R varies directly with I, and R varies inversely with D squared. Once we have that information, we construct our first model. And the first model is to help us find the K. Okay? The constant K. Once we have that, we're going to go ahead and construct our final model. And this is the model that will help you answer any question in the problem, like the question that the problem wants you to answer. Once you have done that, it's just simply doing substitution, multiplication, and some divisions. Okay, so again, the final answer for this example was 1.53 ohms. It looks like a mess, so make sure you follow what I'm saying. Okay, let's look at this other example right there. Okay, so this one is not as bad. Maybe we can breathe and feel like we still got this. La 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 la. Maybe we should try some colorful pens or whatever. Okay, so question 11 says list the intercepts and test for symmetry. Okay, I know it's a lot of red right here, but don't worry about it. You know, this is more like definitions for you to make sure you know it. So if you're looking for the x-axis symmetry, you want to replace negative y in the equation and simplify. So you want to replace y with negative y. I think I skipped this part right here. I'm supposed to replace x with negative y. But you know now, okay? So here, if you're testing for the x-axis symmetry, you're going to replace the y with negative y and simplify. If you get an equivalent answer, then it's symmetric with the x. And then for the y, when you're checking for y-axis symmetry, you want to replace the x by negative x. Simplify. If you get an equivalent equation, then it's just symmetric with respect to the y-axis. Now, to check for the origin symmetry, you go ahead and replace the x with negative x and the y with negative y. If you get an equivalent answer, then you have symmetry with the origin. Okay, so first let's look for symmetry, and then we'll talk about the intercepts. Okay, because we have to do both. We have to list the intercepts and check for symmetry. Okay, so I'm gonna first check for the what am I gonna do? I'm gonna check for the x symmetry. So x-axis symmetry, which means I'm gonna substitute the y with negative y. And if I get a equivalent equation, then it has x-axis symmetry. Negative y squared is just y squared, which equals x plus 4. Well, if you notice, this is the same as the original one, so it does have x-axis symmetry. Okay, so yay. Now I'm going to go ahead and check with y, and I'm going to substitute x with negative x. Well, that's just negative x plus 4. That's not equivalent to the original, so it does not have. Now, if usually doesn't have, let me go ahead and highlight this part right here. I don't know, I think this is too colorful. I'm just going to use it here, and then I'm not going to use it more. Okay, then origin. I'm going to replace y with negative y and x with negative x. And I'm going to simplify. That becomes positive, which is good, but this one It's negative, and this is not equivalent to the original, so it does not have origin symmetry. So we tested for symmetry. We found out that it does have x-axis symmetry. Now, in order to find the intercept of a given equation, if you're looking for the x-intercept, you're going to replace 0 for the y and solve for x. And if you're looking for the y-intercept, you're going to replace 0 for the x and solve for y. So, keep running out of space. I did not thought about this beautiness very well. But because I don't want it to look like the mess that we had at the top, I'm going to erase this because hopefully you already got it. And if not, it's a video you can always rewind. Right? Yep. I know you said right. Okie dokie. So now I'm going to go ahead and look for intercepts. I'm going to look for the y-intercept first. Which is weird why I did y, because I usually always do x. So I'm going to substitute 0 for the y. Okay. I am losing my mind. It must be because I'm so hungry. I'm going to substitute 0 for the x because I'm looking for the y. Okay. That's just 0. So it's just y squared equals 4. Take the square root of both sides. Y equals plus or minus 2. Okay, so that's the y-intercept. And you want to write it as a point. So 0, 2 and 0, -2. Perfect. And then looking for the x-intercept. I'm going to go ahead and substitute 0 for the y. Okay. So for x, -4 on both sides. -4 equals x. And we write it as a point. So -4, 0. So this you have 1 intercept for x and 2 intercepts for y. So first thing we did was to test for symmetry, and we found out it does have x-axis symmetry. And then we have 3 intercepts. Okay. And then in this example, we have the same scenario. We're going to test for symmetry, and then we're going to look for the intercepts. I'm going to do my best to be as organized as possible. That way we don't run out of space because, man, it looks such a mess, right? So let's first go ahead and do the symmetry. So let's look for x-axis symmetry. Okay, so I'm going to replace the y with -y. So I'm going to have x squared plus -y minus 16 equals 0. This gives me x squared minus y minus 16 equals 0. So you can see that is not the same as the original. So you have no x-axis symmetry. So then I'm going to look for the y-axis symmetry. And I'm going to replace x with -x. -x squared gives you x squared. This is equivalent to the original. So yes, you do have. Maybe I should use yes and no's. Right? Because that x just looked confusing there. So no and yes. Okay, now we're going to look for origin. Okay. And here we're going to replace both. And now, I don't know if you have noticed it, that sometimes you can already determine that if it's not for one of these two, then it's definitely not for origin. But it's always good to do the work. Okay, so this is x squared minus y minus 16 equals 0. So again, not equivalent, so that's a no. Now we're going to look for our intercepts. Let's this time look for x-intercept first. Okay. So in order to look for the x-intercept, I'm going to go ahead and substitute 0 for y. Okay. I can move the 16, then square root both sides, and it's going to be plus or minus 4. I could also factor this using the difference of squares. So when I get my answer, I'm going to have 4, comma, negative 4, which is x equals 4, x equals negative 4. Write it as a point is 4, 0, 4. 4, comma, 0, and negative 4, comma, 0. And then the y-intercept. Okay. Go ahead and substitute 0 for x. This is gone, so I'm left with y minus 16 equals 0. And add the 16. So then y equals 16. And my point is 0, 16. Okay. So then you have your 3 intercepts. This one right here. Okay. The x-intercept, the y-intercepts. And then we know that it has y-axis symmetry. Okay. Let's see. In this example, let's just stick with black. Says find the real solutions to the following equation. Again, this is it's not a square root, it's a cube root, but we need to isolate the radical. So the first thing we're going to do, we're going to go ahead and add the 5 to both sides. Oh, look at that line, not even straight. Okay, 2, 3, 4x plus 1 equals 9. And then in order to cancel the cube root, we're going to go ahead and cube it 3, both sides. Bam, bam, that cancels. We're left with 4x plus 1 equals, what is that, 729? I can't remember. Do you guys remember? Do you know? Yeah, it's 729. Okay, minus d1, boom, 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 728. Divide by 4. And that gives you what? 182. And you want to check it. But once you check it, it does give you a valid solution. So x equals 182. Every time you have square root or cube root equations with radicals, you want to go ahead and always check your solution. Okay? In this case, I know it checks. You know what? Let's go ahead and do it. Let's stop being lazy. Right? Professor, you're getting lazy. You do not want to get lazy. No, it's not that I'm lazy. It's just that I'm getting hungry. And I can't stop. Okay. So once you have inside, you're going to end up with 729 minus 5. Okay. Then the cube root of 729 is 9 minus 5, which is 4 equals 4, which is true. So this is a valid solution. Okay. And this is to check. Okay, perfect. Beautiful. Okay, fun. Now, I apologize for my, really not so good graph over here, picture image, okay? So the question says, find the center and the radius of the circle. Write the standard form of the equation. So you are given a circle, okay? Well, let's read a little bit about a circle. A circle is a set of points in the XY plane that are a fixed distance r from a fixed point hk. The fixed distance r is called the radius. I think we know that already. And the fixed point hk is called the center of the circle. And we'll learn more about that a little bit later on, okay? So The standard form of a circle, the standard equation of a circle is this. You must know this to help you answer any questions. So they want us to find the center and they want us to find the radius. Okay, so the first thing we're going to do is find the radius because we are given, if you notice right here, the center of the circle, and then we're given a point. This is everything you need in order to find R. So the center is there. You can see that. Okay. So let's substitute these values. We can go ahead and label it. So we have -2, -3, HK. And then we have 0, -3, XY. Okay. So then let's go ahead and do the substitution. Okay. 0 minus -2 square plus -3 minus -3. Notice how I'm using my parentheses. Square equals R square. This is negative times negative is positive. 0 plus 2 is just 2. 2 squared is 4. Okay? Negative times negative is positive. -3 plus 3 is 0. 0 squared is just 0. But I write it there. 4 plus 0 is just 4. I'm solving for R. Not R squared. So I need to go ahead and square root both sides. Okay? In order to cancel this little square here. So then I have R equals 2. Now you also have R equals -2, but we're talking about a distance. And we cannot have a negative distance. That's why we stick with a positive number. Okay? So then the standard form of the equation, now that we know the radius, is going to be x plus 2 square plus y plus 3 square equals 2. Well, why? But this is negative over here, right? And then why do I have a positive over here? Because the point HK is negative. So when I substitute it in here, it becomes negative times negative, turns into a positive. Okay? That is why. Things that you must consider to make sure we do it correctly. So we have the equation. We have the center. And we have the radius. Okay? One more example. Let's see what this is about. Okay. The volume of a gas B held at a constant temperature in a closed container varies. Ooh, we're talking about variation again. Let's underline that. Varies inversely with its pressure P. If the volume of a gas is 500 cubic centimeters, cc, when the pressure is 300 millimeters of mercury, HM, MM, HA, can't talk, you can see it. Find the volume when the pressure is this. So we're dealing with variation and we're dealing with inverse variation. So this is what inverse variation is. Okay, and it says varies inversely with its pressure. So we're dealing with the first part. Y varies inversely with X. So just like the previous examples, we first identified that we're dealing with variation and which type of variation we're dealing with. Then we go ahead and write what each of our variables mean. So the volume of the gas is B, so I know that B is the volume of gas. And then the next is P, which I know is the pressure. Okay, and then it says the volume of the gas held at the constant pressure in a closed container varies with pressure. So I know that B varies. I'm not going to have enough space, so let me just write it somewhere else. Okay, I know that B varies inversely with P. Okay, so again, once we have labeled our variables, know the type of variation, we're going to go ahead and construct our model. And this model is to help us, okay, find our final model that will answer any question in the example. So then I have, this is from the definition. So B equals, I do not know K, and I'm dealing with P. Now I need to find K. Let's find the K so I can construct my final model. Okay, so I know the V is the volume of the gas. So they're telling me that at 500 cubic centimeters, the pressure is this amount. So they give me two variables, which means I can go ahead and find the K. So this gives me 500 equals K over 300. When you multiply that, K equals to, what is a K? 750. No? Let's see, 300 times 500. It doesn't give you 750. It gives you a humongously big number. Okay? So now construct final model. Final model. Hopefully you can understand what I'm saying and also understand what I'm writing. So then I have B equals 150,000 over P. Now, what is it they want me to find? Find the volume when the pressure is 200 ohms. Find the volume, 200 millimeters HM. So now that I know P, I can simply substitute that. And that gives you 750 cc's. Let me write that 750 a little bit better. I don't know, the fives don't always come out that good, right? You probably were able to tell that, right? So with the idea of this example, again, we were able to see that we were dealing with a variation, right? And then it was inverse variation, right? Once we know that, then we go ahead and label our variables, what each variable means, and then which one varies with what. Then we construct the model using the definition right here. And the next step is to find the K. Once we have found the K, we're able to construct the final model that will help us, right? This helps us solve for the problem. That's what we need. We need to find the K in order to solve the problem. Okay? Right there. Once we have that, we can answer any question that is regarding volume of the gas or pressure. Okay? So we went over 15 questions. You will see these 15 questions in the test. Again, I apologize for the handwriting. I am working on it. Okay. Any questions? Any mistakes that you see, please post them in the comment section so I can fix them or correct them for next time, because then I'll just continue making the mistake if no one helps me. You know, this is a two-way communication. I help you, you help me. Any questions? I'm here to help as always. Okay.